Hello, this is the day 9 homework for Mrs. Sorrentino and Mr. Kenzie's Algebra 2 math class. According to the U.S. Census website, based on the U.S. population in 2010, the probability that a randomly selected man is 65 or older is 0.114, and the probability that a randomly selected woman is 65 or older is 0.146. Assume these events are independent. In the questions that follow, round your answers to the nearest thousandth, which would be the third decimal place. Question A, if a man is selected at random and a woman is selected at random, what is the probability that the people selected are 65 or older? All right, so if we have probability of, and we know they're independent, so we take the probability of a man that is greater than or equal to 65, multiply it times the probability of a woman that is greater than or equal to 65. We will get these two here. Therefore, this and, because they're independent, multiplying these two probabilities together will give us our and or our intersection. So therefore, it is 0.017. Question B, if two men are selected at random, what is the probability that both the men are 65 or older? All right, so the probability, once again, they're independent. All right, so this is an and. All we're doing is we're multiplying both of those. Okay, because the probability of a man greater than or equal to 65 is 0.114. We multiply those together to get 0.013. C, if two women are selected at random, what is the probability that neither of them is 65 or older? So now we're thinking of the complement of woman being 60 or under 65. So we have 1 minus what that original probability was, because this is the probability of a woman greater than or equal to 65. So we subtract that from 1. So the probability of a woman being less than 65 would be 0.854. So now we're selecting 2, so we just multiply those two probabilities to get 0.729. Number 2, in a particular calendar year, 10% of registered voters in a small city are called for jury duty. In this city, people are selected for jury duty at random from all registered voters in the city, and the same individual cannot be called more than once during the calendar year. Every year, the selection process completely starts over. So being chosen the first year and being chosen the second year, for example, are independent events, basically because it resets after the calendar year. Question A, what is the probability that a registered voter is not called for jury duty in a particular year? Well, if the probability of being called for jury duty is 0.10, then no jury, or not being called, would be 0.9, because you 1 minus 0.1. B, what is the probability that a registered voter is called for jury duty 2 years in a row? Well, the probability of each year is 0.1, so we multiply those to get 0.01. Number 3, a number cube has faces numbered 1 through 6, and a coin has 2 sides, heads and tails. The number cube will be rolled once, and the coin will be flipped once. Find the probability of the following events. Express your answers as fraction in lowest terms. So you take a look, I drew a tree diagram to the right, 1 through 6, and then for each of them, you could have a 1 in the heads, 1 in tails, and so on. A, the number cube shows a 6, and the coin shows heads. Well, the probability of getting a 6 is 1/6, times the probability of getting heads, which is 1/2. We multiply those, you get 1/12. Now, if you take a look at B, I did this using the addition rule. So we have the number cube shows a 6. So the possibility of showing a 6, you could have 6 in heads, 6 in tails. So I have 2 out of possible 12. The total number of outcomes would be to the right of the farthest branch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Probability of being heads, we have 1, 2, 3, 4, 5, 6 out of 12. Now we subtract 1/12 because we would have an overlap. You don't want to count things twice, so you get an answer of 7/12. Number 4, of the works of art at a large gallery, 59% are paintings, 83% are for sale. When a work of art is selected at random, let the event that it is a painting, be A. In the event it is for sale, be B. So the probability of A, which is being a painting, would be 0.59. Probability of B would be it being for sale, would be 0.83. I want to represent those as decimals or fractions. Suppose you are told that probability of A and B is 0.51. Find A or B. Well, we know that the probability of A is 0.59. We know that the probability of B is 0.83. The reason why we're subtracting, once again, because this is the overlap. This is what would be, if I had a Venn diagram, the intersection right here. That's what we're subtracting so we don't double count. So when we do that, we should get an answer of 0.91. C, suppose now that you are not given the information in part B, but you are told the events A and B are independent. Find A or B. So A and B, all right, is equal to, because they are independent, the probability of A times the probability of B. So if we multiply those, we get 0.4897. So that is your AND. So now for the OR, we always have to subtract the overlap. So we have the probability of 0.59 for A plus the probability of 0.83 for B, and then we subtract the overlap, which we just found, to give us an answer of 0.9303. Number 5. Kevin will soon be taking an exam in math, physics, and French. He estimates the probabilities of his passing these exams to be as follows. So 0.9 would be to pass, so therefore 0.1 would be to fail. 0.8 would be to pass physics, so 0.2 would be to fail. 0.7 would to pass French, therefore to fail French would be 0.3, just subtracting it from 1. What is the probability Kevin will pass all 3 exams? So we are multiplying these. Passing math, passing physics, passing French. You get a probability of 0.504. Question B, the probability that Kevin will pass math but fail the other 2 exams. So 0.9 would be to pass math. 0.2 would then be to fail physics, and 0.3 would be to fail French. You multiply those and we get 0.053. Now the next one requires a little bit of work. It says Kevin will pass exactly one of the 3 exams. So he could pass math and then fail the other 2. He could pass physics and fail the other 2. He could pass French but then fail the other 2. So I took these probabilities, passing math, 0.9, failing physics, 0.2, failing French, 0.3, failing math, 0.1, then passing physics, 0.8, 0.3 for failing French, failing math, failing physics, passing French. The reason why we're adding these is because